The general name for a three-dimensional solid is a polyhedron, and all that requires is that every face of the three-dimensional figure is a polygon. So these three drawings here are examples of polyhedra. This one has rectangular faces, this one has triangular faces, this one has some trapezoids and rectangles. A more specific name for some special types of polyhedra would be prism, and a prism is what you call it when the top and the bottom, the bases, are the same shape. The bases have to be the same shape and size. They have to be congruent. So, and then you name it for whatever the bases are. So if it's rectangles on top and bottom, it's a rectangular prism. If it's triangles, we call it a triangular prism. And if it's hexagons, we call it a hexagonal prism. And the third that we're going to talk about is pyramids. And it's kind of like a prism, but instead of having the same top and bottom, we have one shape on the bottom, and then it comes to a point. So all the sides have to be triangles so that they meet at a point. With a prism, all the sides are rectangles. So in a pyramid, we call that point where they all meet the apex. The height is the perpendicular distance from the base to the apex. We also have the slant height, which is actually the height of the triangles that make up the lateral faces. And again, we name it for whatever the bottom shape is. If it's a triangle, then we call it a triangular pyramid. Square, we call it a square pyramid. And if it's a hexagon, we can call it a hexagonal pyramid. If the pyramid is standing perfectly straight up and down, like this first example here, then we call it a right pyramid. In that case, all of the lateral faces will be isosceles triangles. The second example, the square pyramid, also appears to be a right pyramid. But this hexagonal pyramid is not right. You can see how it is slanted, so we call that an oblique pyramid. So let's look at an example where we name the shapes that they show. So this first one, we were told that the base is a regular pentagon. And we'll also notice that it comes to a point, so it is a pyramid, and it's going to be an oblique pyramid because it's not isosceles triangles for the side. So a pretty specific name would be an oblique pentagonal pyramid. For this, we can see that there's squares on both the top and the bottom. That means it's a prism. So it is a square prism. And just like we talked about with pyramids, you can also say that prisms are either right or oblique. So since those appear to be right triangles, we can say that it is or right angles on the bases. It is a right square prism. If you look at this, the bottom and the top is in the darker shaded, and this rectangle on top, those are not congruent. So looking at it that way, it's not a prism. However, the front face and the rear face, those are both congruent trapezoids. And it does appear that it is right angles here, so this would be a right, that's a trapezoid if you look at the base. Prism. And that's referring to the front face and rear face. And then our last example here, we do have an equilateral triangle for the base, and it is a pyramid because it comes to an apex up here. So it is a triangular pyramid. And it does appear to be a right triangular pyramid. And to be a little bit more specific, since we're told it's equilateral, you can include that in the naming. So it's a right equilateral triangular pyramid. Same thing with this pentagon up here. It could be we call it an oblique regular pentagonal pyramid. And just like with polygons, we talked about regular polygons. With polyhedra, we can talk about regular polyhedra. And those are when the faces are all the same regular polygon. So, and it's been found that there are only these 5 regular polyhedra. The tetrahedron, which is regular triangles for the 4 faces. The cube, or the hexahedron, which is squares, regular quadrilaterals. The octahedron, which is regular triangles. And octa means 8, hexa means 6, there's 6 faces. Tetra means 4, there are 4 faces. So that's where these names come from. Icosahedron, also regular triangles, but there are 20 of them grouped together. Icosa means 20. And if you take regular pentagons, you can get the dodecahedron. Dodeca means 12. 2 and 10, 12. So, I said that those are the only 5, but if you look at a soccer ball, you might think that it's a regular polyhedra, but if you look a little bit closer, the gray or black squares are pentagons, and the white ones are hexagons. They are regular pentagons and hexagons, and it's only those 2 shapes that make up the entire soccer ball. So that is a semi-regular polyhedron. So I have been using the term face to talk about the polygons that make up the polyhedra. The edges are the lines that make up the sides of the polygons, and then the vertices are all the corners. And Leonhard Euler came up with a formula that actually related the faces, vertices, and edges for any polyhedra, not just regular ones or semi-regular, but any polyhedron. And that is faces plus vertices equals edges plus 2. For any polyhedron, this is true. And for completeness, let's go ahead and talk about cylinders, cones, and spheres. A cylinder is basically a prism with circles for the bases. It can be right or oblique, but it's a circle for the bases and one rectangle that just wraps around the side. A cone is like a pyramid with a circle for a base. Also can be right or oblique. Still has slant height and height. We still call the point the apex. And then a sphere would be kind of the equivalent of a regular polyhedron, but of a circle. So we do have the center of a sphere, the diameter, and the radius still. But it's just a ball, it's just a sphere.